Assalamualaikum and a very good evening to Madam Serdi and all my fellow classmates. We are from CS2476B1 are going to present about network topologies, which is linear arrays, meshes, and KD meshes. Our group consists of 5 members. Here is a short introduction of ourselves.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad RAFIQIE bin ISHAK. My number matric is 2019771351. Okay.
Hello, my name is MOHAMAD Roslan, ID matric 2019T50905.
Hi, my name is SITI BINTI Roslan and my matric number is 2019707165.
Hi, my name is Muhammad Nur bin Muhammad SALEHEN from class CS2476B1. My matric number is 2019175385.
My name is SYAKIRA binti RASHID, matric number 2019720139.
Communication made on a mesh network topology may take any of several possible paths from their source to their destination. In a full mesh network, each workstation or device is connected directly to every other, and in a partial mesh network topology, some devices may be connected to all the others, while the remainder share information directly only with certain other workstations that they require priority communication with. Mesh network topologies are typical of the Internet and certain wide area networks. The data may be transmitted via a routing logic, which is determined by set criteria such as path of shortest distance or avoid broken links. The data is transmitted via two methods, which is routing and flooding. Routing is where nodes use routing logic to work out the shortest distance to the packet destination. In contrast, flooding is where data is sent to all nodes within the network, and flooding doesn't require any form of routing logic to work. The current issue about this network, it is considered expensive. In order to configure this network, it has to create point-to-point dedicated links between each pair of nodes. A link can only facilitate only those devices which is connect. No other device can share a link between other two devices. And for this purpose, it requires a large number of network cables and network devices. This causes a lot of cost expenditure, and that is why it is most expensive. But because of that, it provides high reliability, performance, speed, and security. The ZigBee is an example of this type of topology.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Today I want to present to you about linear array. Linear array is a static network in which each node, except two nodes at the end, has two neighbors. One to the right and another one is to the left. Okay. Then we refer to the diagram A. Diagram A, suppose that this is the first node, the second node, the third node, and the fourth node. Okay. Therefore, the second node has two neighbors, which is first and the third, while the third node has two neighbors, which is second and the fourth. The first and the fourth node is at the end of the network. Therefore, it will only have the one neighbor. If the first and the fourth node is connected, then it will refer to as one-dimensional torus or a ring, like in the diagram B. This is the first and the fourth node connected, and it will shape a ring. Therefore, it will has the characteristic of the ring topology. Okay.
Mesh topology. How does it works? First of all, we need to understand that mesh topology is divided into two categories. First, fully connected mesh topology. Second, partial connected mesh topology. So, as we can see, at the left, This is fully connected mesh topology, and at the right, this is partial connected mesh topology. Okay, let me explain about fully connected mesh. In a fully mesh topology, every computer in the network has a connection to each of the other computer in that network. So as we can see here, every computer is connected to every computer. Like, you can assume this computer connected to the left, is connected direct to the this, and this, from this to this, and this to this, and so on, like the others. Every computer connected to every single computer. So the number of connections in this network can be calculated by using the formula n bracket n minus 1 over 2, which n is a number of computer. Okay, we know that total of computer is 6. So our n is 6. 6 multiplied by 5 divided by 2, we get 15, right? So let we count one by one. We know that circle 1, 2, 3, 4, 5, 6. 6. So we count this 7, 8, 9, 10, 11, 12, 13, 14, 15. We cannot count the other because it's duplicate. So the formula is exactly has a result total number of connection in that network. A mesh topology is a network in which all the network nodes are individually connected to most the other nodes, because there is no concept of central switch, hub, or computer. Mesh topology is not like the other topology which has main, hub, or switch, because this topology has every single independent computer. So most of mesh topology network are not true mesh, because practically if you think about mesh topology theory, we cannot create a real mesh topology. Here we can see mesh topology movement from my GIF. From here, the data, assume the ball is the data, and it's arrive. It will pass through using the route from each connected cable. So next, partial connected mesh. So what the difference about partial and connected? Okay, let me explain about the partial first. In a partial connected mesh topology, at least one or two computers in that network have connection to multiple other computers in that network. Okay. As I said, at least one. And we can see in this partial connected mesh topology, every computer except this computer has not every single connected from direct connected from the other computer, but this computer has direct connect from this computer to this computer to this computer to this computer to this, and this to this, while the others, like this, only direct three node cables. So in the event that one of primary computer connection in the network fails, the rest of the network continues to operate normally. Okay, assume this computer somehow is broken, and if this computer want to send something to this computer, usually this computer will use the shortest route, which is from this to this to this, right? But if this computer is broken, this computer cannot use this route because it's already unavailable. But he can use alternative way, which is from this to this. It's not the shortest, but at least the data is not interrupted. There is no any central device like hub or switch in partial connected mesh. It seems like a fully connected mesh topology. So, what the difference between fully connected mesh topology and partially connected mesh topology? Okay, the only difference is, first, the formula that has been created to find the total number of connections in this network only can use in fully connected mesh. And second, this partial connected mesh topology only require at least one of the computer in the network have connection to multiple other computer in networks, while a fully connected mesh, it needs every single computer in that network has connection to every single computer in that network.
KD meshes. How does KD mesh works? The general class of KD mesh refers to class of topologies consisting of D dimensions with K nodes along each dimensions. KD mesh family is formed by linear array. The other extreme is called hypercube, which consists of topology. Next, let's move to hypercube. There's a few dimensional for the hypercubes. First, zero-dimensional hypercubes. It consists of 2 power of 0, which is 0 nodes. It is like a dot that doesn't have any connection with other dots. Next, one-dimensional hypercubes. It is constructed from 2 of zero-dimensional hypercubes, or as we can see, the 2 dots that connected with each other. The two-dimensional hypercubes is 4 nodes, which is formed from 2 of one-dimensional hypercubes by connecting corresponding nodes. Generally, D-dimensional hypercubes is constructed by connecting corresponding nodes of two D-1-dimensional hypercubes. For example, if we want to form 3D hypercubes using the formula given, let D equals to 3. And then minus with 1, we can get 2. It means hypercubes with 4 nodes or 2D hypercubes. To form 3D hypercubes, we need 2 of 2D hypercubes. Other example, if we want 4D hypercubes, let D equals to 4 and minus with 1, and we can get 3. So, we need 2 of 3D hypercubes, as we can see in the diagram. The distance between any two nodes is at most log P, where P is total number of nodes.
I'm going to talk about the benefits and advantages of the mesh network topology. First, it is flexible and highly reliable, even in the most challenging environments. In mesh network, every device connects and collaborates with its neighbors. The mesh network is also stronger and more resilient as more devices are added. It automatically checks its neighbors to find multiple reliable connections. If you have an electrical outage, it automatically finds an alternative chart, or as the landscape changes, the mesh automatically responds. They maintain dedicated links between nodes, which means if one link fails between two devices, it does not affect the entire network. Lastly is their robust security and authentication to control access. For example, if a rogue device attempts to join the network, it should be identified and blocked. Next, we're going to see the drawbacks or the disadvantages of this mesh network topology. Firstly, there is a high chance of redundancy in many of the network connections. The overall cost of this network is too high compared to other networks. This is because this network requires a huge amount of cables, which will subsequently make the cost to rise. Lastly, the setup and maintenance of this topology is difficult, which means even the administration of the network is high compared to other network topologies. These are the references that we use for this topic.
We hope you could understand the linear arrays, meshes, and KD meshes better now. Thank you for listening.